Welcome to the second of 4 planned videos sharing outreach activities that I've done for many years on the astronomy of Harry Potter. This video is going to be on making a model of the Milky Way, making a galaxy model. Where would I get the idea of a galaxy model having anything to do with Harry Potter? Well, this comes from Harry Potter and the Prisoner of Azkaban, where it says, while shopping in Diagon Alley, quote, Harry was sorely tempted too by the perfect moving model of the galaxy in a large glass ball, which would have meant he would never had to take another astronomy lesson, unquote. Well, we won't get into the idea that perhaps Harry shouldn't have been looking for shortcuts in his education. And think about what it would mean to make a moving model of a galaxy. I'm actually wondering if J.K. Rowling really meant solar system here, but let's go with galaxy. First, of course, we have to define what a galaxy is. So a galaxy is made up of billions and billions of stars. I won't even try a Carl Sagan imitation here. Also clouds of gas and dust, and invisible dark matter that acts like glue to hold all of this together with its gravity. And if you want to explore a bit more about galaxies, I've given you 2 links here. The first link is to NASA's Space Place, and that is meant for younger children. And then I've given you a direct link to an area of the regular NASA website, which has a whole tremendous amount of information on galaxies and pretty pictures. So I recommend that you take time to explore with your children or just explore yourself all of the wonderful pictures and information that we now know about galaxies. Galaxies come in different shapes and sizes, and the name Hubble, which might be hopefully on the tip of your tongue from the Hubble Space Telescope, but the Hubble Space Telescope was named after a real person, astronomer Edwin Hubble, who about 100 years ago looked at different galaxies and saw that they came in these different shapes and sizes and classified them based on their shape. So we have elliptical galaxies, which are named because they look elliptical, and then we have spiral galaxies that look like pinwheels, and then we have these weird things called barred spirals, which are spirals that have this stretched out structure in the middle that we call a bar. Both spirals and barred spirals, of course, have spiral arms that makes them have that pinwheel type shape to them. And then we have a catch-all category irregular for the galaxies that have had a tough life and don't have a pretty shape to them. Now, both spirals and barred spirals look like pinwheels when you look at them face on, or top down, you might say, or bottom up, I guess. But if you turn them on their side, you see that they're actually very thin, and I usually liken them to fried eggs. They're sort of bulgy in the middle. That would be the yolk of the fried egg. And then they're thinner on the edges here. That would be sort of the white part of the egg. And so here we have some beautiful spirals and barred spirals that are turned on their sides. Now, spirals and barred spirals have different parts, and in these different parts, we have different types of structures. So, for example, the stars here in the center part of the spiral galaxy, what we call the bulge, are generally older than the stars on the spiral arms. The spiral arms are places where baby stars are currently being born. So we need to have both young stars found in the spiral arms, and we need to find the material out of which baby stars are formed. And a lot of young stars, like the Pleiades here, the 7 sisters, which were introduced in the first video, they still have some of the material left over from their formation surrounding them. You can see that the blue starlight is scattering or bouncing off of the dust that is surrounding the stars. And this is what we call a reflection nebula. And if you look very carefully in this color photograph, you can actually see some parts of the spiral arm that have sort of a bluish tint to them. And that's exactly what we're seeing here, a reflection nebula, blue light bouncing or scattering from stars off of dust. And then you also see these areas here that have this reddish pink color. And these areas that have the reddish pink color are what we call an emission nebula. And we can see one right here. This is the so-called Rosette Nebula, which is surrounding one of these star clusters in the center. And again, this is gas which is left over from the formation of those stars. And that hot gas glows with a distinctive color due to its chemistry. If you want to do a little bit of homework, you should go and look up what's called hydrogen alpha emissions. And so we can see these pinkish red nebulae scattered throughout the spiral arms. And again, that is indicative that that is a place where baby stars have been born and where there's ongoing star formation. Now, surrounding our fried egg, we have something different. So here's our fried egg is seen edge on. This is a cartoon of that. And hopefully you can see that there is what looks like a swarm of bees above and below that fried egg, above and below the plane of the galaxy. And they make something that we refer to as the halo. And in the halo, we have very, very old stars, the oldest stars in our galaxy. Now, most of the stars in the halo are isolated, individual stars, which makes them hard to see because they're just individual stars. But there are several hundred accumulations of many, many old stars together in one place. And when you have many, many old stars, perhaps 500,000 to 1 million of these, their accumulated light makes them stand out like a beacon. And these are objects that we call globular clusters. It's a cluster because it's many stars together, and it's globular because it looks like a glob. It has a round or spherical shape to it. Here is a cartoon of our Milky Way. And again, this is not a selfie because we have not been out of the Milky Way where we could take a selfie. But you can see that our Milky Way is a barred spiral galaxy. And the location of the sun and the solar system is not at the center, and it's not out at the edge. It's between the center and the edge. You'll normally hear about halfway between the center and the edge, and we are located on the edge of one spiral arm. Now, what I do with kids is I make a model, not a moving model in a glass sphere like Harry Potter was looking at Diagon Alley, because I don't have that kind of budget, right? So what I do with kids is I make a very simple model of a galaxy that has all of the, quote, moving parts that you can see in a real galaxy. So what you need to do is you start with a dark piece of construction paper. Black is great, or if you have dark blue or purple or whatever's lying around the house. And then I usually draw with a silver Sharpie an outline of a spiral galaxy, something to get them started. So I make the central bulge, and I usually make that a little elongated so you can hedge your bet as to whether you want to have a spiral or a barred spiral. And then I outline a bunch of spiral arms. And this is going to be for the children to trace out and add to. And here's where the arts and crafts come in. If you have glitter glue or have access to glitter glue, that is best because that will make less of a mess. Notice I did not say that it would make no mess, just that it would make less of a mess. You also need some regular glue and you need some cotton balls. If you don't have cotton balls, if you have any quilting batting or anything that's like cotton balls. And so here are some models that students have already made. You can see that they have used the glitter glue to color in the central bulge. And if you look carefully, the glitter glue that they've used is a yellow color, or if you don't have yellow, you can use orange. Remember that actual photograph I showed you of that face on spiral. I pointed out that the bulge had some older stars in it, and so they're typically stars that are similar to our sun in terms of, stars that are yellow. You might have some orange or red stars as well. So the accumulated glow of the center of this galaxy is going to be closer to the yellow end of the spectrum. But remember on that photograph I showed you of the spiral galaxy, we had those blue areas where you had starlight from hot young stars reflecting off of dust. And so you can put little blobs of blue glitter glue. And then we had those pinkish red areas, which are the hot glowing clouds of hydrogen where baby stars have been born. And again, you can trace that out with red glitter glue, or the closest color you can get to red glitter glue. If you have a maroon or even a purple will sometimes work. If you don't have glitter glue and you're really brave and you have real glitter and glue, go for it. You already know what sort of mess that's going to make. Now, to make the globular clusters, that is where the cotton balls come in. So you take cotton balls and you rip them into tiny pieces, and then you glue the individual tiny pieces to make this halo surrounding your galaxy. Now, a question that people will ask is, if we're stuck inside the Milky Way and we can't take a selfie, how do we know what it looks like and what does it actually look like to us? Now, if you're fortunate enough to live away from a city, you can go out and you can actually see this hazy band of light stretching across the sky. That's what the name Milky Way actually came from, the Milky Road across the sky. And in other mythologies, it's given different names. For example, in some places in Africa, it's called the backbone of the night because it's believed to be the spine of the sky that keeps the stars from crashing down upon us, because that really wouldn't be a good thing. If you look very carefully, you might be able to trace out the teapot of the constellation Sagittarius, which is going to be play a central role in a future video. Now, if we look towards the constellation of Sagittarius, we're looking towards the center of the galaxy. We can't actually see the center of the galaxy directly because there's just too much stuff between us and it. And when we say we can't see the center of the galaxy, I mean with visible light, the light that we see with our eyes. But there are other kinds of light that are invisible to the human eye, and we can actually use those to pierce through that gas and dust. So for example, here's an infrared picture looking towards the center of the galaxy, and you can see that it looks like there's some interesting stuff going on. Here is the center of the galaxy seen in X-rays, and you're really starting to get a hint that something's going on there. Something interesting is going on. Here's the center of the galaxy seen in radio waves, and you can see that there's definitely an area of high energy at the center of our galaxy. And so what's going on? Where is all that energy coming from in the center of the galaxy? I'm going to give you a little homework assignment. I'm going to ask you to look up what's at the center of our galaxy. And this picture might give you a little bit of a hint. I have here a bunch of websites that you can check out. Obviously, nasa.gov, and you can just put in Milky Way or center of the Milky Way. The Hubble Space Telescope website is also great. But remember that I've shown you that we can look at the center of the galaxy in kinds of light that are invisible to our eye. So I've given you a link here to the Chandra X-ray satellite, the Spitzer infrared satellite, and radio astronomy, the National Radio Astronomy Observatory, so you can look at more about what's going on in the center of our galaxy in radio waves. So I hope you've enjoyed this. I hope that even if you aren't going to be playing with glitter glue, that you'll at least investigate what's at the center of our galaxy and look up some of those links. Comments are always welcomed, and I'll be seeing you soon with part 3 of our Astronomy of Harry Potter.